In this video, we are going to be looking at some statements and determining whether or not we think they're true or false. And for everything that we think is a false statement, we are going to provide a counterexample to disprove it. So, the first statement right here is that no five-gon is concave. If you remember, concave means that you have a cave in your shape, so it's going to look something like that, where you've got a shape and on the inside you've got a cave here. Now, with this shape, it's very easy to see this is concave, but it's not a five-gon. I think that this is a false statement. I think that there are five-gons that are concave, and to show that this is a false statement, I just need to come up with one counterexample. Well, that counterexample needs to be a five-gon, it needs to be what we're talking about, and it needs to be concave. Well, I'll start by drawing out what I want to show. This is going to be something that's going to look like a concave part. That's two sides. I just need to show that I can make a polygon with three more sides, and then it'll be a concave five-gon. So if I have 1, 2, 3, I can now count this out. I have 1, 2, 3, 4, 5 sides. This is a five-gon, and it is concave. So I've just shown, using this counterexample, that this statement is false. All right, let's move on to the second one. If you add two acute angles, their sum is always obtuse. If you think about that for a moment, I am going to say right off the bat, I think this is false, and let me try and come up with an example as to where that is false. If I add two acute angles, so that means I need to have an acute angle, another acute angle. I'm going to need to be adding them, and I want it to be something that is not obtuse to come up with a counterexample. So let me try and come up with two acute angles that add up to remain still acute. Well, if I do 5 and 3, this is an acute angle, it's less than 90 degrees. This is an acute angle, it's less than 90 degrees. 5 plus 3 adds up to be 8 degrees. That's still definitely an acute angle. Well, this is a counterexample that follows everything that I have in the statement. I'm adding two acute angles. That's what they say is going to have to make it. But when I add them up, it's not obtuse. They're saying anytime I add two acute angles, their sum is always obtuse. And I just showed, hey, here are two acute angles that I add up, and they add up to an acute angle, not an obtuse angle. So that means that this statement is also false. Well, what about the opposite of that statement? The sum of two acute angles is always acute. Well, in this case, I had an acute angle plus an acute angle, and that was acute. But is that always going to be so? I'm going to say that this is false also. What if I have two acute angles like 70 and 30? 70 is an acute angle, it's less than 90 degrees. 30 is an acute angle, it's less than 90 degrees. But if I add them up, they add up to a 100-degree angle. This is obtuse. Or in other words, it's not acute. So here's another counterexample proving that it's not always acute when I add up two acute angles. That means that sometimes it's obtuse, sometimes it's acute. But both of these statements that are saying always, they are not true, and I showed that by doing counterexamples. Let's go through two more. The only prime doubles are 3, 5, and 5, 7. By the way, a prime double is a pair of primes where the second prime is 2 greater than the first. If you forget what a prime number is a number that is only divisible by itself or the number 1. So something like 7, I can only divide 7 by 7 or 1. If I divide it by any other number, I'm going to end up with a decimal answer. So 7 is a prime number, 3 is a prime number, 5 is a prime number. The only prime doubles are 3, 5 and 5, 7 is what this claim is saying. Well, let's come up with a couple more prime numbers. I've got that 2 is a prime number. It can only be divided by 1 in itself without having a decimal remainder, or without having a remainder, or without having a decimal. 3 is a prime number. 5 is a prime number, 7 is a prime number, 8 is not prime because it can also be divided by 4, 9 is not prime because it can also be divided by 3 and end up without having a decimal. 10 is not a prime number, it can be divided by 2 or 5. 11, though, can't be divided by anything other than itself or the number 1, so 11 is prime. And then 12, that's not prime, it can be divided by 3 and 4. 13 is a prime number. So I've got a couple more prime numbers. Let's see if I can come up with a prime double. So I've got 3 and 5, those are prime doubles. That's their first one. 5 and 7 are prime doubles. How about 7 and 11? Well, these are two prime numbers, but 11 is 4 greater than 7, and this is saying that a prime double is only 2. So 7 and 11 is not a prime double. But what about the numbers 11 and 13? If I look, 11 and 13, they're both prime numbers, and 13 is 2 greater than 11, so that's my counterexample right there. 11 and 13 are a prime double, and so that means that 3 and 5 and 5 and 7 are not the only prime doubles. This is my counterexample, and this is a false statement. Finally, 2 is the only even prime number. Well, a prime number is a number that's only divisible by 1 and itself without getting a remainder or a decimal. And if I take a look at this, I really can't think of any counterexample because any even number, I know it's divisible by 2. If you come up with any even number, at the very least, it's divisible by 1, itself, and the number 2 as well. So I'm going to say I think that this is true. I can't prove it 100% yet, but there's also really no counterexample that I can come up with.